Find the area between the curve f of x equals x squared minus 16 and the x-axis between x is negative 4 and x is equal to 4. The graph of the curve is shown. So we can remember that for a function f, where the graph is below the x-axis for x is an element of a to b, the interval where we're finding the area for, we can calculate that area using these formula. So we can either introduce a negative sign here, because the definite integral of a to b for f of x dx will be negative if the curve is below the x-axis. So by multiplying by -1, we ensure that the area becomes positive. Or alternatively, if you don't want to introduce the negative sign, you can swap the terminals. So here we integrate from b to a instead of a to b. So that's two options for making sure that you get a positive area out for this calculation. So for this question, I'm going to use the first option where I'm going to use a negative sign to make the answer positive. So I'm going to have negative the integral between -4 and 4 of the function, which is x squared minus 16 dx, and that's going to be equal to -2 times the integral of 0 to 4 for x squared minus 16 dx. And that's because this area here is symmetric to the area over here. So if I just calculate one lot of those and double it by introducing the 2, I'm going to get the same value. So what we need to do is remember that I can calculate this by calculating the antiderivative of x squared minus 16, which is going to be x, and we add 1 to the power and divide by the new power, and then subtract 16, and then we introduce the variable x for the constant terms. So that's the antiderivative of the function, and we evaluate this between 0 and 4, which is simply equal to, we can't forget the -2, and then f, capital F, is just the antiderivative evaluated at 4, subtract the antiderivative evaluated at 0. So if we calculate that, we still have our -2, which we can't forget about. And then f of 4 is the same as 4 to the power of 3 over 3 minus 16 times 4. And then we subtract away the antiderivative evaluated at 0. So I'm going to have 0 cubed divided by 3, subtract 16 times 0. And now everything in there is just 0. So we don't have to worry about that. That simplifies down for us. And we're just left with -2 bracket 4 to the power of 3 is 64 on 3. Subtract 16 times 4 is 64. And if you evaluate that, you find that it is equal to 256 over 3. So we can say that the area under the curve is 256 on 3 units squared. So that's all of that area there, the blue and the yellow. So that obviously doesn't have an exact decimal, which is why I've left it as a fraction.